Okay, so in this video I'm going to talk about continuity of functions. Now, I'm just going to talk about two different types first of all. So you've got, I'll just draw two axes here first. So this is x, y, and y again. So let's say we have a function that looks, I don't know, let's say, just do it something like this and then something like this. So you can see there's a break here, and just draw that again here a little bit better so it looks something like that. Okay, so there's a break in the function here, so you can see intuitively anyway that it's not continuous. And we've also got these kind of functions here where we got a little gap here. So these type of functions here are not continuous, and this one here is called a jump. This one here is called, I'll put it down here, jump discontinuity. So that's a jump. So you can see that the graph actually jumps up or down here. In this particular case here, this one is called a removable discontinuity. So this here is called a removal discontinuity. So you can have a little gap here, and maybe the x value is not defined here along this curve here, but it's actually moved down to here, or it could be up here somewhere. So this is a jump discontinuity, and this is a removable discontinuity function. Okay, so let's look at something else here. So let's say we take an x and y axis again, and we'll take a function along here like this. Okay, so if we take any value here, let's say this one here, and we'll call it a here. So we can see here, we can see intuitively anyway that this is continuous. There's no breaks, no jumps, no gaps. We'll say this is L or f of a here. Now if the limit of our function, this is our function f here, if the limit of our function as x approaches a is equal to f of a, then the function is continuous. Then f is continuous at a. So in other words, if you get the limit of the function approaching a from the left hand side and the right hand side and so on, and it's equal to L, and you also put a into your function, and you also get L, then the function is continuous at a. So there are no gaps here. Okay, let's have a look at the next one. So if the function is not continuous, then, so let's take a function that looks like this. We put a little gap in here again, and let's take this here as our a here, and we have a limit here, and let's say a here is defined here. So in other words, f of a will be here. So this is f of a here. So in other words, our graph moves along nice and smoothly here, and then suddenly at a, it's not defined normally anymore. It jumps up to here, or is removed, I should say. This is a removable discontinuity, and it's defined over here. So in other words, this graph is not continuous at a because the limit of our function as x approaches a is not equal to f of a. So when we put a into our function, we don't get our limit, we don't get the limit, we get something different. We get this value up here, whereas our limit is down here. Okay, so we can also look at a function like this where we have endpoints. So let's say we have a function that looks like this. So we have endpoints here and here. We can say that they are continuous at these endpoints from the right or from the left. So for example, if we take this point here, let's say this is A, and let's take this one here and we'll call this one C. I'll actually just change this one slightly. I'll just say that this is not defined here. So I'm just going to put in a little, actually do it in the same color here. So put in a little circle here. Now, and let's say that's defined, I don't know, let's say here some. Okay, so let's look at these two endpoints. So again, this is our function f of x. Now let's look at a first of all. Now we can say that the limit of our function as x approaches a from the right, so in other words this direction here, is equal to f of a. So in other words, there's our f of a there, and that's equal to the limit from the right here. So we can say that it is continuous at a from the right. It is continuous at a from the right here. Now if we look at this endpoint here, we can see that the limit from of f of x as x approaches c here from the left is not equal to f of c. So therefore it's not continuous from the left here. So that's just looking at the endpoints here. But you got to be careful here. We don't know what the function looks like down here, so we can't say, or even up here, so we can't say that the function is continuous from the left and right here, if you like. Okay, so that's it on continuity of functions.